Here are the instructions for solving problem 2 on exam 1. The problem states, solve the following problem graphically. Please be neat. As a suggestion, I would like you to use the Excel template to plot the constraints, the objective function, and the polytope. I want you to show all calculations for determining the XY intercepts of the constraints and the objective function, and I would like you to shade the feasible solution region using the software called GIMP. So for this problem, each person in the class will be assigned a different objective function and different constraints. So I have maximize z is equal to the assigned objective function, column G, subject to these two constraints. So what I would like you to do is to go to the Excel file that I have posted, ENMA 603 student template, find your name, and in the columns E, F, and G, these are going to be the equations, the objective function, and the two constraints that you will use to solve the problem graphically. So for example, let's suppose that you are a student 2. Your objective function is going to be 3x1 plus 1x2 is equal to 18. So your problem would read, go ahead and copy this. Your problem would read, maximize z is equal to 2x1 plus 1x2 is equal to 10, subject to the first constraint. I'm sorry, I accidentally picked student 1, but let's just go with student 1, equal to this constraint, which is going to be 1x1 plus 1x2 is equal to 9, and then the second constraint, which is this constraint, is 4x1 plus 1x2 is equal to 12. So the first student would have this model that I would like you to solve graphically. Now, I have provided a template for you to solve this problem graphically. But before you can use the template, you must first determine the XY intercepts of the objective function and the constraints themselves, along with the intersection of the two constraints. So my template does not do that for you. All the template does is just allow you to plot these constraints and objective functions in a nice standard format. So basically these 1, 2, 3, 4, 5 sets of coordinates define these 5 line segments. This line segment, this line segment, this line segment, this line segment, and the red line segment, which is the objective function. So as you can see, as I change these numbers around, these coordinates, the coordinates of these line segments, also change. So once you have determined the coordinates associated with the line segments, you can simply plug them in and then create this nice polytope. So once you have this polytope created where your red line segment just touches the corner of the polytope, and once you determine what those coordinates are, what I want you to do is to click on this and simply just copy, and then open up a PowerPoint presentation and paste, and then just click on Disable Macros, and this will bring this into your PowerPoint presentation. And now I would like you to label using a Times New Roman 12 font each one of these constraints. So let's suppose that the objective function was 2x1 plus 3x2 is equal to, say, 15. These are numbers that I'm just making up for demonstration purposes. I would like you to make sure that you put these subscripts, move this over, and let's suppose this was the objective function here. Then just create a curved line identifying this objective function. And then if you right mouse click on this curved line and go to Format Auto Shape, you can create an arrow. So then just click this and hit Shift, and it allows you to select two or more items, and then if you hit the control button and your up and down or left right arrow keys, you can place this in the correct location. So that is there's one objective function. Now just copy and paste this, say for this constraint, and copy and paste for this constraint. And obviously you're going to have to place in whatever these parameters are for that particular constraint, and then create arrows identifying each one of these line segments like that. And I'll create another one right here. Okay, so now you have created, and like I said, obviously all of these are going to be different for your problem. You have created these three equations, and now simply hit Control A, or you can go to Edit and then go down to Select All, select everything, right mouse click on one of the objects and go to Group. So what you have done now is you have grouped all of these together, so when you move them around, they're together. But the problem is this is still in a kind of an Excel PowerPoint format. So if I were to copy this, Control C, and then paste this into a Microsoft Word document, you see what happens. You are pasting in an Excel spreadsheet, and sometimes it causes it to hang up. Other times it's trying to paste in all of the data associated with this. So what we need to do is we need to convert this to an image. So the way I'm going to go about doing this is I'm going to go back to my presentation, copy, right mouse click, copy, and then I'm going to use this software that is open source software that I have provided for you on Blackboard, and simply click on Edit and go down to Paste As, and then click on New Image, okay? And see what this does is this pastes this graph along with these lines and equations. It pastes it as an image, not as a not as a linked or embedded PowerPoint or Excel file. And now we can go in and edit this image. So I want you to click here on the bucket tool, okay? And then click here on this color. It's probably a different color on your computer. Maybe it's black or red or something like this. And what I want you to do is I want you to plug in this color right here, which is D7FFFF. Okay, this is the hexadecimal color. So plug in the standard color. It's kind of a light blue color, D7FFFF. You should be able to type that in. And now when you click on this shaded region, see how it fills this area? It fills the polytope. And you're probably going to have to zoom in a little. So the way you can zoom in is you simply just hit the plus arrow key. And then if you notice here, 0 and 6 are still white, so I'm going to fill in those colors. And then zoom out. And now I have this nice, neat polytope that I have created. Simply click on File, Save As, and it's usually best if you save this as a JPEG format. So I'm simply going to save it on my desktop. I'll just call it Figure 1 or whatever you want to call it, figure1.jpg. Click on Enter, and it'll say, okay, you can't do that, so we have to export it. And then save the JPEG quality as, say, 100%, and then hit Save As. And now what we have done is we have created a file here that has this nice, neat polytope with all these constraint lines and the objective function. And now you can use this. You can, it's in this task, you can now import this into a Microsoft Word document. So now let me bring up this. And now if I simply go to Insert, Picture from File, and go to my desktop, and that was called Figure 1. And then when I insert it, see now we have inserted this nice, neat graph that has the polytope, all the constraints, and the objective function with all of the intersection values. And now you can make this larger or smaller, whatever you decide. So I would like you to do this when creating the polytope for the first exam. So if we go back and look at the first exam, basically I want to make sure that you show all of your calculations for determining the XY intercepts and constraints, and then I want you to graph the polytope using the Excel template that I have created and make sure that you shade it using GIMP.